when we think about the sun, it's like this giant ball of fire, right?
Right.
But here's the thing.
Yeah.
The sun's outer atmosphere, the corona, it's actually millions of degrees hotter than the surface. Millions.
It's crazy.
It's crazy. And it's been a paradox, like a puzzle for scientists forever.
Yeah, for a really long time.
So today, we're going to dive deep into a new theory that might finally explain this.
Okay.
We've got this research paper by Avihay Bastekar.
Okay.
And he's proposing this thing called magnetic wave cascade amplification theory, MW Shiket for short.
Okay.
But honestly, the name's a mouthful, but the concept itself is even wilder. We're talking like quantum mechanics in space, little explosions called nanoflares, and a whole new understanding of how the sun produces all that energy.
This is a really interesting one. Like you said, the simple question, why is the corona so hot?
Right.
Has really stumped some of the brightest minds in astrophysics. It breaks the laws of thermodynamics. You'd think heat would flow from the hot stuff to the cold stuff. So the surface should be the hottest part. And it should cool down as you go out.
It's like you're standing next to a bonfire. And you're feeling the air around it. Hotter than the flames themselves.
Yeah, it's so counterintuitive.
It doesn't make sense. So how have scientists even tried to...
So there have been some theories, but none of them are perfect. Magnetic reconnection, that's where magnetic field lines in the corona break and reconnect, releasing a bunch of energy.
Got it.
Then there's wave heating, where waves from inside the sun travel out and heat up the corona. And then we have nanoflares, which are like tiny explosions on the surface, releasing bursts of energy.
So all of those kind of make sense, but none of them really hit the mark.
They don't really explain the whole picture.
Like they each explain parts of it. But...
like pieces of a puzzle. But not the whole thing.
Not the whole puzzle. That's where MW Shiket comes in.
Exactly. It kind of brings it all together. It's not like it completely throws those other theories away. It actually uses those theories and adds quantum mechanics to it.
Whoa, quantum mechanics. That's a whole other...
It's a whole other stuff.
Like, I think of quantum mechanics as subatomic world stuff. Not this fiery sun.
Exactly.
So how does this... how does this all work?
Okay, so imagine you throw a pebble into a pond. You see the ripples. Now imagine throwing a whole bunch of pebbles. All those ripples would start overlapping and interacting.
Like some would get bigger and some would cancel out.
Exactly. And that's kind of what's happening.
With the nanoflares.
Yeah, the nanoflares are like the pebbles creating these ripples
of
magnetic waves in the corona.
Got it.
And they interact and amplify each other through this cascade.
So it's not just...
reaction?
Yeah, not just the nanoflares themselves, but...
It's the waves they create.
It's the chain reaction that heats everything up.
It's pretty wild.
It is wild. But I mean, I'm assuming there's some serious math.
Oh, absolutely. There's a big equation at the heart of MWSat. It describes how energy density...
Like how much energy?
Yeah, how much energy gets packed into a certain space is affected by things like magnetic field strength, the distribution of nanoflares, and importantly, how these waves interact.
Right. And that's what's different.
Yeah, it's all about the interaction
the other
theories. One of the key things is how it includes quantum mechanics. You see, old models thought energy was the smooth flow. But quantum mechanics tells us energy exists in these little packets. Quanticar's equation takes this into account.
So it's not just describing the transfer, but the fundamental nature of
the quantum nature,
the energy itself. Exactly. Okay, but I mean, this is all very theoretical.
It is, but
how do we know if it's actually...
That's the beauty of it. It's testable. Bastekar made some really detailed simulations of the corona.
So he took the equation and put it in a computer.
Yeah, and built a model of the corona.
That's pretty cool.
And what he found was amazing.
What did he see?
These crazy patterns of energy cascading through the corona. The waves were interacting exactly how the theory predicted.
Wow, So it's not just that the math works,
right?
But it's like
it predicts real-world behavior.
Yeah, yeah.
And here's the other thing.
Yeah.
The theory predicted these higher energy levels.
Than the other theories.
Yeah, than any of the other theories.
But maybe this is why.
It could be the
The corona is so hot.
Yeah. It's pretty exciting.
Really cool. But I mean, simulations are one thing.
Yeah.
Can we actually observe this?
Well, that's the next step.
Okay.
MWCat isn't just a theory. It actually makes testable predictions.
So we could
point telescopes at the sun.
Yeah.
And actually look for this stuff.
Look for
evidence.
Yeah, what kind of evidence?
Well, one prediction is about these nanoflares. Remember how we talked about them being like pebbles?
Yeah, creating those ripples.
Right. Well, MWSCAT says those nanoflares shouldn't be evenly spread out.
So they'd be like clustered in certain areas?
Yeah, in specific patterns.
Like hotspots.
Exactly. It's like rainfall.
Okay.
Sometimes you have heavier rain in certain spots.
Right.
It's kind of like that with nanoflares.
So if we could see that,
yeah,
that would be good evidence for MWSCAT.
It would.
But wouldn't we need like really powerful telescopes to see those tiny explosions?
Luckily, there are new solar telescopes.
Oh, cool.
That are being built right now.
Okay.
They can see the sun in amazing detail.
So maybe those could actually...
They might be able to...
map out the nanoflares.
Exactly, and see if the patterns match.
Okay.
What MWCat predicts.
But that's just one thing, right? What other evidence is there?
There's more. MWCat also predicts specific wave patterns in the corona.
Oh, right, from
those ripples.
Yeah.
Interacting.
So it'd be like looking at the pond and seeing areas where
the ripples get bigger.
Yeah, and areas where it's calm.
Exactly. And MWCat says we should see similar patterns in the corona.
With magnetic waves instead of water.
Yeah. But of course...
We can't see those.
We can't see them with our eyes.
Right.
But we can use instruments.
What kind of instruments?
They measure the polarization of light.
Polarization? That sounds complicated.
It's a bit technical, but basically light waves vibrate.
Okay.
And magnetic fields can change the direction of the vibration.
Okay.
That's polarization.
Got it.
By analyzing the polarization, we can map the magnetic fields.
So if we see the patterns that MWCAT predicts, then that would be more evidence.
It would support the theory.
This is so cool.
It is pretty amazing.
That we can use light
to
figure out
it's like a puzzle.
What's happening inside the sun.
It shows how all these different fields are connected: astrophysics, quantum mechanics, optics.
It all comes together.
Yeah, it's a beautiful thing.
But even if we see all this evidence, couldn't there still be another explanation?
That's the thing about science.
Yeah.
There could always be other explanations.
Right.
But a good theory should not only explain
what we already know,
what we see, but also predict new things.
Okay, so what else could we look for to...
Well, we could try to measure the energy of the nanoflares.
Directly?
Yeah, directly. See if the energy they release matches what MWCat predicts.
That would be pretty conclusive.
It would be a strong confirmation.
Okay. Anything else?
We could also study the particles.
Particles?
Yeah, in the corona.
Okay.
MWT says the waves should accelerate particles to very high energies.
So if we see that...
It would be another piece of the puzzle.
Wow. So there's
a lot more research to do.
A lot more to learn.
Yeah. It's an exciting time.
It is. Okay, let's take a step back.
Okay.
If this is all true...
Yeah.
What does it all mean?
That's a big question.
Yeah.
If MWSCAT is right, it means quantum mechanics.
That tiny world stuff is affecting a star.
Yeah, a star.
Which
is enormous. It's a huge shift in how we think about things.
That's not just about the sun.
It's about the universe.
Yeah, and how
these different areas of physics.
Yeah, like quantum mechanics and astrophysics are connected.
Yeah.
And that's just from asking that one question.
It's a simple question.
Why is the corona so hot?
It's amazing.
And it leads to all this other stuff.
Yeah, it opens up so many possibilities.
Like what? What else could this lead to?
I mean, this is all super cool, but why should, a normal person care about this?
Like, what does it matter to us on Earth?
That's a good point. It's easy to forget. Yeah.
That the sun is kind of important.
Kinda.
Well, very important.
Yeah.
It's like the reason we're all here.
Yeah.
It gives us light, warmth that powers our weather, everything.
It's like the engine.
It is the engine
of our planet.
Yeah. So understanding how it works is important if we want to understand ourselves and the Earth.
Right. But you're saying it goes beyond that.
Oh, yeah. The sun is like this giant lab where we can study stuff that happens
in the universe.
Everywhere in the universe.
So by studying one star...
You learn about all stars, galaxies, everything.
It's like a window.
It is a window into the universe.
Yeah. And M.W. Cat, if it's true, tells us that quantum mechanics, that tiny stuff, could be affecting stars and galaxies.
Whoa.
It's like the same rules that govern atoms are also shaping the universe.
That's a lot to think about. It is.
So we started with this simple question.
Why is the corona so hot?
Yeah. And it led us to
all this crazy stuff.
Quantum mechanics, the universe.
And who knows where it'll go next.
Yeah, like maybe
new theories, new experiments, even new technology.
So this could change the world.
Really change the world.
Yeah.
That's the power of science.
Really cool.
It is. We never know where it will lead us.
Yeah. Well, I think we've reached the end of our deep dive.
We went pretty deep.
We did. We went from the sun's surface...
to quantum mechanics.
...to the entire universe.
That's quite a journey.
It is. So thank you for joining us.
Thanks for listening.
On this deep dive.
Yeah. Keep those questions coming.
Keep looking up at the stars.
And never stop exploring.
Until next time.